In this session, what we'll do is we'll run an actual blockchain application using VS Code extension. There's a voting application already there. We'll run that. We'll go through the code of that using VS Code extension. And 1 year back, it would have been very difficult to set up the network. I mean, it would have taken some time. But IBM has given a VS Code extension, which will do all the heavy lifting for you. Provided you have to have some prerequisite. As soon as you install that extension, it will show you what are the prerequisites you have to install, and after installing, it will just boot up. So we'll go. Before that, what I would like to do is we can revisit some of the concepts which is important for this session. Can you go to the next slide? Murali, can you go to the next slide? Next slide. Yeah. So, 1 minute. Yeah. Can you come back? Slide. I think. Yeah. So, what is chain code? So, in simple terms, if we have to understand chain code program, it is the business logic of your Hyperledger fabric. So, you have decided to do some write some application. For example, it might be anything. Let's take a silly example. We are storing all the cell phone numbers in the Hyperledger fabric, for some security reason. So our chain code will have a logic of when to store, how to store, the check, everything. Chain code is basically the business logic of your Hyperledger fabric. One other way of thinking of chain code is also in a way that it is the one application that interacts with your ledger. So you don't have when you are coding or when your application is running, your application will not have control over the ledger fabric. You just what you do, you invoke the chain code. You use the chain code to talk to the ledger beneath it. Actually, it makes sense, right? If you give control of the ledger to the application, then the application might do malicious activity. Okay, so this chain code extends the APIs, the stubs, basically for you to interact with the fabric. So in this chain code is installed in every peer. So if you ask me, what is the core part of Hyperledger? Who form code? The peers form, because peers hold the ledger, and peers, some of the peers are endorsers, some of the peers are members. Those peers hold the ledger, and also those peers host the chain code. Each peer will host the chain code. You can run parallel chain codes in your one peer depending on the chains you have. We'll come to that. So basic, if you ask me, basic, what is the structure of the chain code? You have decided to write a chain code, and how would it look like? So first thing you have to have is init function. Even init is a empty function. You have to have it. It is the standard. Init is called when a chain code receives an instantiate or upgrade transaction. So if you want, when you're instantiating a chain code, init is called. So it may perform necessary initialization, like creating the assets of your application. Creating asset might be as small as, for example, directory, phone directory, or in insurance, something else. So initial asset, what you have to do when you run your chain code, it will be in init function. Along with the init, other thing is invoke function. Invoke actually invokes a transaction, right? So if you have to do let's say you have a wallet, you have to spend 10 rupees out of your wallet. That is a transaction. So that transaction needs to be in the blockchain. So for that, what you do is in chain code, you use the invoke function. That invoke function in turns right to the blockchain. So one more time, you control the ledger, use the chain code. Chain code, peers, orderers form the core of the Hyperledger fabric. Can we go to the next slide? Yeah. So one other concept is ledger. So ledger, what is ledger? Actually, we have been talking ledger. So in basic sense, if you want me to explain a ledger, a ledger is a store, some sort of database. If not database, it's a some way of storing the data. It stores important factual information about the business object. It doesn't only store the business object, but it stores the factual information about the business object. Let's say uh, you have some kind of asset, some piece of land you have, and uh, you try your initial state of that object is you have the whole piece. Let's say small example, you have one fruit. You that is the initial state of the object. That fruit is an object in your hand. So you decide to take a piece out of it and give it to someone else. Let's say you already gave it. How you gave it doesn't matter. Then the fruit again reached another state. It is a half a fruit now, but that is the object. So in ledger, what happens when you take the piece of that fruit and give it to somebody else, that transaction is also stored in the ledger. That ledger maintains the state of the object in the throughout the history. So if you somebody gave if you give fruit to people, if somebody goes through that ledger, they can track, okay, this time this person gave this much fruit, this piece of fruit to this one. So you have the state, and you can create something in the ledger, but you can never really delete. There is a way to update or delete. If you write a transaction to delete something, it will be another addition that this transaction might be deleted. So if somebody goes to that ledger and sees, then you can see in the ledger that you can see the original state and also the deleted or updated state. So nothing ever really is deleted in a ledger. That what makes the immutability concept. So current of the attribute object and history of the transaction that resulted in these current values. So you are finally are left with a small piece of fruit. Then if somebody comes to you and asks how much, how come it is a small piece, then you can go to the ledger and see all the values. Along in ledger, this ledger in ledger fabric, it is a little bit different concept from blockchain, a traditional blockchain. How it is, we have two aspects to it. One is a world state, the other one is blockchain itself. So let's see what is the world state. The world state is a database that holds the values of set of ledger state. The world state makes it easy for programmer to directly access the current value of the state rather than having to calculate entire transaction log. So you know what you have. Let's again, if you take the fruit example or any example for that matter, you know you have a half a piece of fruit. You don't have to go to the entire ledger to check it. So how it is achieved in Hyperledger Fabric is using a CouchDB. It actually uses every node will have its own DB. There you maintain object state, but not the object history. If you want to know how come you have half the fruit, then you have to go to the ledger and see. So that forms the world state. The next option, next thing is, can you go to the next slide, Murali? Come, yeah, this. So next one is blockchain. Blockchain is actually a list of records, transaction log that records all the changes that have resulted in the current world state. So you cut your fruit into 3 pieces. You kept the major half with you, and other quarters you gave it to somebody else. That transaction log is there, right? That is stored in the blockchain. So your world state, that is your local database everywhere, and the blockchain together form a ledger. As clearly depicted in this picture, you can see the ledger is formed by the world state and blockchain. Any questions at this point? Because these are very important concepts to blockchain and the Hyperledger Fabric.
I think people are asking, explain world state again. I think I'll bring the slides back.
Yeah. Sure. I'll explain. World state. So simply put, I'll not complicate it. I said too much. World state, even though it sounds complicated, it is just a database. The first thing is a database. It might be if you have developed your Hyperledger Fabric on your own, then you might have used any database for that. MySQL Hyperledger Fabric, they have used CouchDB. So it is a database. In that database, you maintain data, but not the log. So you say, I'm going to say one set of pens you have, a pack of have an ID. You store in your DB that this is one pack. The current state is it has 5 pens. Okay. Now your friends comes and asks, give me 2 pens. So what you do, you take 2 pens out of your actually in programming things, what you do, you submit the what you do, you take 2 pens out of it and write in the blockchain. You create a blockchain. In that blockchain, the transaction data will be like this. I previously had 5 pens. Now 2 pens I took it out. Now the state is 3. You make it into a transaction and you add it to the block. Now one block is created in the blockchain that has entered data. Now in your database, you reduce the actual from 3 or 5 to 2. In your database, in that ID pens now, you give your friend 2 pens. So if you go and check in your database, in front of that ID, you have 3 pens now. But how you came to that idea, how you came to that state, 3 pens, go back in the blockchain, see the ledger, okay. On that day, I had 5 pens. I gave 2 to my friend, so it became 3. This transaction is stored.
Yeah. So in another analogy, if I just want to give in the same context for world state and a ledger is, for example, a financial data in case of we maintain, assume that n number of banks does, there's a lot of credit and debit statements and a profit and loss statements within a bank. That all is maintained inside a bank ledger, right? But the world state is something, assume for the conceptually, saying that it is a income transactions, what has happened, only the final data has been given to the world state. What is that final data is just how much, what is the transaction amount. It is not entire process is being told to a world state. World state preserves only the data which is required for the final state of the data. So that will be stored there in order to simplify the entire process. Okay. So yeah.
So in case of a mistake, so what you do is that if you let me, if I am the chain code developer, what I do is that I'll give an option called mistake. I'll give an option called mistake, and in mistake, I'll write this transaction ID mistake. So I'm changing this transaction. So I'll write new transaction ID, transaction, what was the mistake and what is the correction, and I add that block again. So person who is going through that block will be...
Excuse me, Mr. Adithya, there is a participant who wants to ask a question. Can I unmute? With asking to unmute.
Yeah, sure. Go ahead.
Okay.
Hey, thank you very much. This is Murugan this side. If I understand correctly, for L ledger, okay, blockchain is the redo log file kind of a thing. And blockchain, what is that? It is the redo log file of the world state W. Is it correct?
Correct.
Okay. So this is the terminology Hyperledger is using actually. Okay, so redo log is in Oracle database, any database where we store the current transaction. It is up to the database to take the redo log file to the database. Similarly, I did not bother about blockchain here. It is the Hyperledger responsibility to go and store it up in the L actually.
No,
Or do I have to
actually,
give any instruction to go and write blockchain to L?
so yeah, I'll tell. There are many aspects of it. So this blockchain is there, right? We are not using any database for that. The blockchain B, what you are seeing now in the screen, system. In file system, that blockchain will be there. As you tell, you can view it as a redo log, because if you go from one end of blockchain to the last end of blockchain, you can create the world state properly. So this combination, the world state will, and blockchain will also be maintained in each of the blocks. W and B will be in each of the peers. So ledger, what I'm calling ledger, its concept is a pair, W and B. So nothing is deleted in W, nothing is updated in W. Only thing you can do is add a block. Even if it is a mistake, you come back and add a block that it is a mistake. If your application requires to delete, you come back and add a block that you deleted it. A whole blockchain is stored in each transaction, as I told you in as I demonstrated in previous demo. Block, every peer will get that block and updated it. So W and B is there, right? The management of it, you don't have to worry about it all, because Hyperledger does everything through its APIs. So what do you do? Yeah, the one thing about peers, it is scalable. So you have to have a peer that is capable, that which have. And frankly speaking, the scalability of Hyperledger is far more than the traditional blockchain, Bitcoin blockchain. If you want in traditional block, if you want to read something, you have to go to blockchain and traverse the entire blockchain to see. But here you can just go, if you want to know the current state, you just have to query your local API. Sir, can you unmute sir, so that he can ask the question? I'm getting confused in text. It's Priya, right?
Priya, yeah,
Yeah, go ahead.
I shall unmute. Yeah. Yes.
Good afternoon, sir. This is just an
Good
example
afternoon.
I'm asking. For example, in a train, there will be a number of tickets available and the number of tickets booked. So that will be available in the world state, where it is holding the current state or the final state. And the people details, who booked, who cancelled, all those details will be in the blockchain. That is what you mean?
Correct, and partially correct, because the world state will also be in the blockchain. So I would write like that. These much tickets were there previously. This much tickets were available. This much tickets were booked. This person booked this ticket. So now the state become that. So I store everything there, so that if you go from one end of the blockchain to the other end, you can create a world state. Let's say your all the peers died, and all the database of all peers died. You lose world state and only left with the blockchain. You can recreate that world state using the blockchain, but it would take
Okay.
long, right? Because you have to traverse the blockchain.
Okay, sir. Okay. then in that case, we need to keep the blockchain itself, right? If I want to find what is the world state, then I need to maintain the whole blockchain with me.
That is the concept of distributed application. You maintain everything in every peer.
Okay, okay, sir.
Otherwise, you lose the concept of distributed, and you give powers to some of the central. It becomes partially centralized.
Okay, so the in addition to the traditional blockchain, you have in addition the world state. But other than it is like the old one.
It increases efficiency. It
Okay.
increases efficiency.
Okay, sir. Thank you.
Okay, now I think we can go for a hands-on session.
I think we have to make you as a presenter.
Yeah, it will be done.
Let me know if you can see my screen or not.
We are able to see now.
Okay, just give me a minute. So yeah, this is the one more VM I shared. If anybody is actually doing it in actually running in real time. So the password is demo 16112020. I believe I have shared the password also. So now what we will do is we'll set up that extension I was talking about. It'll give you an idea of unless invocation. Okay, so traverse to evote repo, evote, and then we have web app which will communicate with our Docker binaries and everything. So let's do one thing. Let's start the code here, VS Code, so that we'll have we can traverse well inside. Blockchain platform extension. You Okay, so this is very easy. They have made it incredibly simple, which was very difficult earlier. So when you click on it, it automatically it pulls some of the data. So environment, it already have a demo environment setup and everything. So here it is showing that simple local network is showing that in organization one to start. So that's all we need to do. We just click.
I think Aditya, your voice was breaking. I think you might have to repeat what you said.
After landing on this VS Code, so if we have 10 particular one, some of them through channel. So the peer will be involved in two channels. One is general, which is connected party.
Aditya, I think there is a lot of audio issue. Even I'm seeing the same.
Yeah.
Maybe you have to disconnect and connect back. I think that would solve an issue sometime.
Okay. Am I audible now?
Yes.
Is it fine?
Yeah, now it's clear.
Network issue.
Yeah.
I'll share. Can you see the screen? Can you?
Yes. Yes, we can see.
Okay. So as you see, I didn't do anything. I just clicked on it and everything got set up. So connected to the one organization here. So what next steps is that, as I told you, the core of blockchain, what forms your business logic, lies in the chain code. So we have already set up a chain code. So what we have to do via smart contract, chain code means what? We can install a smart contract. So in the left panel, go to here in install under you have plus install, is that right? I hope everybody is following me. So you can just click on that install and it shows the options. Voter contract at 700, is that right? That is packaged right now. That if you click on that, that will successfully install a contract, a smart contract. Basically our chain code. Now it is installed. After installing it, we have to instantiate it, start it so that it's run. So how you instantiate? You click on observe now. I click on the instantiate button. I select the contract. Now it is asking what function do you want to call on. So it's asking for a function. So if you remember, can anybody tell me what are the functions in chain code we discussed earlier? Just put it in chat. It might be anything. Right. So we'll call init. You can write your own function. We can write, but the traditional way is to call the init because you have to instantiate. We have to initialize some of the some of the initial everything would have written in init. So in init function. If you see in industry, all contracts will have an init function. Now rest of the things you just keep putting enter and enter. It will take default values. Now it has started instantiating the contract. Okay. Now if you see in the right tab, we have successfully instantiated the smart contract. Two environments here. One environment I have set up for Hyperledger Fabric. The other one is the web app that communicates with this environment. So we have to make sure that this environment is exposed to that web app, right? We'll do that now. So for that, what we will do is, give me a minute. So we'll export all the information. Okay, how we'll do it? The organization. As soon as you click on in Fabric Gateway, you click on organization one, then it gives you an option. You click on the admin. It instantiates some of the gateways. So here, what you can do is click on this 3 button and say that export this connection profile. I want this connection profile. So when you opens up a file directory for you. So you store this in a server. You give it a name fabric connection.js. Fabric connection. There, if I give, it'll ask for override. gateway. One more thing, so since it is a secure network, one more thing we have to wallet details. How you connect to your environment, how you connect to any peer with other using this wallet, private key, all the secret information. How you do is you click on the organization, and here when you click on the organization and you can right click on that, you get an option called export wallet. You're exporting that wallet. So on the export wallet, then you are prompted with again go inside web app and inside server you create a folder. You create a folder called wallet. So I'm going to repeat what I did. I went to the Fabric wallet here in the left corner. In org1, it is important that you select org1 because you are not selecting order, you are selecting for organization 1. So you right click on that, you get an option called export wallet. As soon as you enter that, you are inside web app folder. Then inside web app, where there is server folder, inside server, you're creating a folder called wallet. And inside that wallet, you're storing all the information. You have connection details to the web app. Now, thing to do. Now, app contains two parts. One is a server. One is a node server, Express server, and the other one is a view client, view server. It is just an implementation. They both talk together. So where you can go to a new window here, terminal window. Here, what you do is you navigate to keyword application. There you navigate to web app, and you can see that two options are there. One is server and other is client. What you can do is you start the server first. So you can go inside server. Inside server, what the command you have to run is if you have not installed, you'll have to run npm install server, npm install. Since I'm already installed that in this environment, what we can npm just start. As soon as you go in, we are starting the server. So let it be that this is a server instance. I'll minimize it. Same exercise, new window. Traverse to the voting application. Here we have a client. So what I do, I'll traverse, and inside that client, I'll run the command npm run, and then afterwards serve. Now this is creating all the view function and all the interfaces, user interfaces. So let me repeat what I have done. Since I have got the entire environment set up, now the second thing is we got the environment set up. We add export details to our app. Now in that app, we have started two instances. One is server, another is a UI server. It is running in this environment. This endpoint, localhost 8080. What I'll do, I'll copy this and I'll paste it since okay, as soon as I copy pasted it, we got a interface. Now it is all set up. The server is running. So now let's try to vote. Okay, before voting, we can register here. We will have to register our IDs. Okay, This one I have to remember, that's why I'm giving a sequential one. So I'll give register, something happened. Here something happened. We don't know what happened. So again, I'll try. Now it is saying an identity for admin user admin does not exist in the wallet. Identity is not created. The enrollment.js application before we try. What we have to do is basically take the wallet and create the identity before even starting this. We'll do the same. Excuse me. So again, everything is the terminal. So what we do, we navigate to the application. Keyword, back inside that server. Now, if I ls server, I should see an enrollment admin.js file. This takes your enrolls. So, can you tell the enrollment? Can anybody tell me where the enrollment data is sitting? Morgan said it is just a demonstration. That's why I meant to create that error. So I was asking, when I enroll someone, where the data is there, enrollment data, where will it go? Where is it stored? Can anybody tell me? It's correct in form, but location. Correct, Morgan sir. What you meant to store, what you do, transaction, wallet, everything you initiate, you say that you log the file, that this log is created, everything you put in the ledger, because that's only data store we have. Ledger, what we for W plus B is equal to L, what you plus B, it will go there. So now I'll enroll the user. Node enroll.js. Then what it will do, enroll the user. Yes, successfully enroll admin user, admin, and imported it into wallet. Now we have details in the wallet. Now we have enrolled someone. Now if I go there with 1, 4, 5 voter ID, 2, 3, 4, 5, 6 as my this thing ID and register. Okay, now the voter ID is registered. I can take this 156 voter ID. Pardon the details. I'm just being lazy. I can log in and I can vote it here. So I can give one vote. I can give my voter ID. Everything is getting put to Fabric. See, successfully recorded vote. Or yeah, you can see the message. So what I can go back here and let's see, go to poll standings, check poll. Okay, I discussed with you the init and invoke functions. There are some more functions. There's one more function called query. Query, you just query the data. You don't invoke a transaction. So when you're developing chain code, you can develop in such a way that, okay, you know what, when somebody authenticated user wants to query that data, I don't put in log. My log bigger is just query is stored. So I can write a query function which will query the data. So you can see all the poll here. So there's only one I voted. You can vote some more time and we have the entire poll. So I can go to home, and what I can query all assets. So here you can see the ballot ID, ballot card, the blocks here, entire blocks created, right? So this is the pathway. So let's go into the code. Just give me 2 minutes. I'll come back, and let's go to the code and see some of the comments. I won't be able to show you all the code because it's a huge code base. Some of the key will go into contract. Contract is designed, the smart contract. Just give me 2 minutes. Yeah, sorry for that. I'm back. So now extension in the how you see the extension, and let's go through the code and see what is actually happening. If you see the file system here, you can see here. So here, what we are interested in is that this contract, inside this contract folder, we have something called voter contract.js. If you remember clearly, we imported this contract. We instantiated this contract of that. Okay, so contract API, these are importing some of the files. Sorry for that, and we are importing some of the file. If you come into the contract class, you can see here we are passing a context. This context is nothing but the context of the stub I'm talking about. So I missed this thing presentation. So along with that, how you talk with the ledger in programmatical sense is through a context, a stub interface, an actual stub and its interface. So you create context using of that stub. You don't have to do much of it. You want to invoke a transaction, you just call invoke function. If you want to query, you just call. Internally, Hyperledger Fabric will take care of the rest. So let's see what is happening. So we have voters, we have votable IDs, we have election details, elections. So we create 2 voters. So we push that, and if you see here in the await function, we are pushing context through stub to the state also, and in your blockchain when you do these operations. So what I'm explaining is init function. First time we instantiated, right? This is called. So along with that, what is happening is that we are taking the election object parts. So election and election date we are taking. These are all the initial. As I told you, init will initialize some of the things. So we create an election object and push it to the elections, and finally you push this election to the push Hyperledger fabric ledger. So here we are initiating all the data and pushing it. Whatever you feel like storing something in the, you push it to the ledger. So again, you're creating votable items, and you're pushing it to the votable items, and again you're pushing it to the pushing it to our contacts, your ledger. And after that, for each votable items, we are generating ballot. Ballot is getting generated so that people can. The function when you start it, that these things happen. See how it is happening in the context stub push state. So this is through this fabric contract API. Node.js export install fabric contract.api. So how this is talking to the our environment setup? Remember, we exported the gateway and wallet details. When you do this thing, it will automatically read those details to the transaction. If it fails, you get error message. After that, we have one more. So this is in it. Everybody has, every contract probably has this. And after that, your business logic. We have here generate ballot. If you want a different business logic, create an insurance or create insurance paper, you can write here. So now you should be getting an idea what a chain code is. It's a business logic. You can write a stupid chain code logic, something like adding pen, something like that. That will be inside the chain code, and inside every peer, they all follow the chain code. Same chain code is installed and instantiated, and they all follow it. They all run it. So even though since it is not centralized, it is in synchronization. Every peer will be in synchronization. So this creating ballot is simple. We take votable items and creates the ballot and pushes to the context. Again, of the functions are create voter, like creating ballot, voter, delete my asset. Even though if you're not deleting, even though you're not deleting it, you're actually adding a block saying that something is deleted. Again, read operations. So you go to the ballot.js in the left panel, you see all the ballot code is there, election code, and election.js of the voter. When you create vote object, what are all the quick checks it has to make, and how do you validate voter ID? If you have an API to call that voter ID, you can write it here. You go to contract and see that some of the functions are there, whether the asset exists or not, because whether the voter exists or not. If you want to check, get and call and you can check. Cast vote will actually cast the vote. It will take again the context and the arguments which are picked. Means remember, we will enter here and we'll pick somebody in the list. So this will be picked here, and we create a. We do some of the checking whether they exist or not, it is valid or not, whether they have already placed the order or not, placed the vote or not. Then if everything checks out, we push the state. Okay, is casting the vote. So which carries all the assets in the chain code. Yeah, that is a query object. Yeah, that is pretty much it for contract. Smart contract. Do you have any questions? Okay then. So important part of that contract is our contract, smart contract, our chain code. Then who interacts with chain code is written by the network.js. You can find it in web app server. Inside that fabric, inside you can find net. So this network.js application actually talks to your contract, in turns it talks to the ledger. So the important things libraries we need, and the function of interest is this connect. We connect to the network using wallet information. Remember, we exported the wallet information. We take that wallet information and try to establish a connection here. We check wallet exists or not. If connection is established, then we return a response. Once it is connected, we have an invoke function. Here, what happens is that we are invoking a transaction. We are invoking a transaction here, which in turn it transmits its, it can with a contract, and in turn makes the transaction. In turns makes the transactions in the ledger. So for this function, we pass a network object and isQuery. Remember, there are some query. There are some query operation, and there are from login operation. So here it's designed like that. If you want to query all, you don't ledger, because it's just a query. So if it is put a transaction in, if it is not a query, it will actually do the transaction. Here, if it is query, then before into the ledger, we are evaluating the transaction, whether the transaction is valid or not. How we are doing? We are doing using valid and rest of the thing. Yeah, valids, and it will be submitted to the endorser, and if it comes back comes back with a true, then we submit the transaction with the arguments. The transaction will be submitted, and it in turn communicates with a chain code, and that chain code writes to the ledger. In Invoke, we have similar register, voter, and these are the application details. I won't go much into it. Any questions? Okay, that's all I had. Since I don't know environment supports or not, I can't debug here.
So yeah, I think a team is asking about steps and a process which need to be followed to run this. Yes, we have, I think, Hyperledger Fabric developer community. There is a useful, lot of links are there, but we will provide you a hand-picked ones, which will help you to go through and understand the application which we are talking. This is a very good application. Actually, it will be useful for exploring a blockchain very well on a non-Bitcoin scenarios. I think we can do that. So the question from Anita, I think. Sorry, go ahead, Adithya. I think there's a question for you on the chat window.
Yeah. So it is your design code. How you will write the design code, it depends on that. You don't want everybody to see it, code it like that. The flexibility part of Hyperledger, right? If you want everybody to wrote, you can code it like that. It really depends on how you code your chain code. As I told you, chain code is your business logic.
So that's exactly the difference between private blockchain and a public blockchain. If this concept is on a public blockchain, you don't have an option. Everybody will see. But in case of Hyperledger Fabric, you will have an option where you can avoid sharing that data, or you can restrict the data should be visible to whom and which are the resources. So only those peers will get an access to that. Okay. I think there's another question from, another question from Murugan sir.
So chain code, as I told you, it is the actual business logic, right? Run on the peer. You maintain a peer on your own, it'll run on that peer. Ledger is the environment which supports you to run that peer, right? So chain code will be executed in its own container. No one can touch that chain code. If I'm a hacker and I can manipulate that chain code even though you're executing it, then the entire concept, entire trustworthiness of the Hyperledger breaks. So they put it inside a container like Docker or any container. They run it. I'm not sure next month.
No, I just want to give that answer. Is the NetMask equivalent was there in the Hyperledger earlier? It was called Composer, similar, but it has been discontinued in the year of 2019. They are trying to add that additional features in the some of the features in the Hyperledger Fabric itself, but rest they are leaving it to an application developers. They are not giving. Earlier, if you look at any older samples of Hyperledger, you will see Composer was doing a similar job of NetMask.
So smart code is not stored in Ledger. So smart code is an executable program, right? It's an executable log. Executable instance. You install and instantiate. It's not your data. You're not trying to protect it. Even though it has to be secure, you can have some kind of deployment strategy. How you can the stack, how you can put it into your peers and run it. But smart code is not, in a traditional sense, it's not stored in the ledger. But I believe since it's just a binary, you can have it stored in the ledger.
Okay. So any more questions from anybody?
I will give an option for them to unmute. Probably they can interact. That would be better, right? Yeah.
Yeah, that is also fine. I think otherwise we left with poll questions of around 5.
Yes.
Yeah, we can do that as well. It's a audience choice. We don't have any mandate. We have some couple of questions on a poll. We can go through that, or we can open for open discussion.
Hey, this is Murugan this side. Is there any comparison table between standard blockchain versus Hyperledger? So yes, the feature here is called some kind of a tabular column, if we can share.
You mean to say your question is related to the Bitcoin based blockchain versus the
normal blockchain, actually. Normal blockchain. Maybe you could say like what you call the miner over here. In Hyperledger, we don't have it, or we have it up in a different name. Okay, that we call it up as a blockchain. Here it is called as a ledger, something like that, so that it will give better clarity while we are studying.
So, as I told you earlier, Hyperledger has an extensive documentation. You
Okay.
need to Hyperledger. They also have so many products in there. Also, you can learn there. You have documentations there. You can go through it. They only give you the comparisons also. But you need, if you are going for a performance comparison, then I believe some people have already done it because Hyperledger has been used some. But if you ask me, the this is where Hyperledger Fabric is used, and the business cases Hyperledger solves, and the business case the traditional blockchain solves are two different things. So I don't know is the performance wise. I am 100% sure if you compare performance wise, Hyperledger is amazing.
If I compare
But I'm
Ethereum,
not sure.
if I compare Ethereum with Hyperledger, that's also a valid comparison, or because Ethereum also we have in private, correct? We had a session yesterday. Ethereum.
Yeah, you can compare, I guess. So Ethereum is known to its slowness. On my research, I have seen smart contracts are terribly slow in Ethereum.
So that is why this Hyperledger IBM has introduced for the performance sake this world state and blockchain
As I
ledger
told
and
you,
everything.
scalability and performance are the important parts of Hyperledger, but if you see the business cases it is solving, you still use Ethereum for coins, right? Bitcoin, smart coins, Ethereum coins. You mine them. Even in Ethereum, you mine them. Here, concept of mining. Here we are solving different set of business cases for insurance application, for supply chain. We are using for even application logs. They store it somewhere. Application logs can
Suppose the
also be stored.
consensus, see, who does the consensus across the peers actually? Or it does automatically?
No, consensus are there actually. Murali, you want to take that question?
I think we lost Murli.
Yeah,
His voice was
consensus
breaking.
Sorry. Okay. Is it my voice is audible
in
now?
the
Yeah, now it's clear.
Yeah. So if you remember in the morning session, I was talking about an endorsement policy and an endorser requirements. So that decides actually in the Hyperledger who need to do and what role has to be played is defined by the endorsement policy. Why? That is because since this is a private blockchain, there is a people can or a code can decide whom should act on what level. So that's completely in the control of code designer or a business case requirement.
and endorsement authority service something is there, so it can assign roles to the peers.
Thank you.
Thank you, sir.
Any more questions? Mr. Murli?
Yes.
I think you can go in for the poll. I guess there are no more questions.
Okay, that would be great. I think you have to switch the presentation.
Sure.
This is actually, I'll just continue because we had a couple of questions. It will be fun for the closing a day with the clear things and understanding. And also we will be able to get the gauge of how much has been understood and any area of improvement can be done. So I'll start polling of a couple of questions more. The same formula, it'll in the morning, the way we did it, we can just try out. So a minute. So the poll is getting open. So this is the most interesting topic, what we all discussed. I think it's a simple as well. We'll start answering. Timer is on. Twenty seconds more. Okay, done. I'm just waiting for the 49 out of 120. I would encourage everybody to participate. If you have any challenges, do let us know. The next question is on the order of which executes. So as part of the content emailer, you will get all the answers for all of these questions. So final answers so that we can cross-check all of those things. Okay. So 47, only 3 more is added. Is it question is difficult or is it not presenting on the screen properly? Any challenges, technical? Do let us know. The next question is on the way. Yes, here it is. Oh, got it. I think mobile phone people are using connected from mobile phone is not able to see. Yeah, that's right. I think the questions would be a little bigger. its polling will not be designed particularly for a mobile phone concept. I can understand that. Okay, good. I think now it's improved. 54 people have attended. Then just 2 more questions and then we'll be done. So this data I'm just trying to, we are going to utilize for analysis purpose so that it will give us a clarity on how our concepts has been thought through. The next question I think is open. So it will be a one answer, not multiple answers. It's just
Yeah,
okay,
it says
maybe
3, select 3.
Oh, sorry. I think it's a question back. Got it. Understood. I think that's a fault in the question itself. Sorry about that. Okay. Okay. User chain code question. Here we go. It's the last question for the day, and we can done with after that. The last important topic of blockchain. Twenty seconds more. Okay, 16 seconds more. Awesome. So now we get exactly a 51% of the voting on this. This is what exactly happens on Hyperledger consensus. More than 50%, it will be a done. So thank you very much. I think this was wonderful engagement from morning. I appreciate everybody's patience. I know this we just touched upon at very 60,000 feet high level on the topic because the concept is little difficult to understand on a first go, but all we need to do is just understand the basic foundational blocks and the design, what difference we are making from the existing concept. So if we just attack that problems, easily we'll be able to understand. And I hope we just did a good justice to the basic understanding for the concepts. The code might be a little difficult for understand. So anytime you can reach out to our email IDs, send out email IDs if you're stuck anywhere. We'll give a kind of the document which will clearly tell about what we gone through the entire session, the process, what we did for the basic code, as well as the Evote application. Evote application will give really a good exposure on understanding. You need to spend at least a month or two on Evote application. If you do that, you will be a perfect in Hyperledger Fabric. And it's going to be one of the biggest open source contributor. Even though IBM is doing it, it's not owned by IBM. It's open source still, and only IBM Cloud is the most production version they are managing on one side of that, but it's still an open source. Every code which is written in that by every developer is available to access. Okay. So with that, thank you very much for the entire audience for their patience, as well as the BIT and for the FTP program, and all the best.
Thank you. So anytime you need any help, you can reach us. I will share my email ID. And also Hyperledger community is really friendly. You can contact them. And they also, the first landing page also have a lot of case studies. So you can go through that case studies, how they're actually solving real-time problems, security problems. Thank you. Thank you for the opportunity.
I thank Mr. Muralidhara Mallur and Mr. Adithya Nadig for an excellent session diving deep into the concepts of Hyperledger Fabric and exhaustively covering the concepts for the entire day, addressing all the queries by the participants. And I also must add that they have taken a lot of time to give you the setup, the prerequisites that they shared, though it was a little late that was shared yesterday. Probably that is the reason why many could not, install it due to the entire day of being in the FTP here. So kindly go back. We have shared it in the Google Classroom, so you can install it. The recording of the session will be available, so you can redo. I mean, whatever has been taught in the FTP today, by them you can recheck and redo it again through that. So thank you so much for all the efforts that you have put in, Mr. Muralidhar and Mr. Adithya. Thank you so much for getting associated with this FTP. And thank you for accepting our invitation. It was an excellent session. Thank you very much.
Yeah, that's our honor.
You.
You're welcome. Yeah.
Yes. Thank you. Thank you.
Thank you.
Thank you. And tomorrow, again, the session starts at 10. I thank all the participants. We completed day 3. So we shall all meet tomorrow for another day of this faculty development program at 10 o'clock. Thank you.
Thank you.
Thank you, Mr. Murali and Mr. Adithya once again. Thank you.
Thank you.
Thank
Bye-bye.
you. Bye.